Hello once again. In this video we're going to be looking at how to balance redox reactions using the ion electron method, and we are going to show you bit by bit or step by step. If you have been given a reaction such as, I'll start with a very simple one, magnesium reacting with oxygen to give you your magnesium oxide, right? So, and we need to balance that. First things that you need to do is to identify species that have been oxidized, and you also need to identify species that have been reduced, and then from there we write the net ionic equation. So in this case we start off and say to ourselves, okay, here's the magnesium, it's reacting with oxygen. What happened to the magnesium? Well, we look at the oxidation number of the magnesium, and then from there we look and say, okay, initially its oxidation number was equal to 0. Why was it equal to 0? This is because the magnesium was in its elemental state as a solid, and its oxidation number is going to be equal to 0. So it reacts with the magnesium and then with the oxygen, and then it becomes magnesium oxide. In magnesium oxide, the oxidation number of the magnesium is equal to +2. How would you know that? You say, okay, fine, there's the magnesium, it's unknown. We want to calculate its oxidation number. So it's x plus minus 2 is equal to 0, therefore x is equal to +2. So the oxidation number of magnesium in magnesium oxide is equal to +2. So what has happened? The oxidation number of magnesium has increased from 0 to +2. It has increased, and we would say that it has undergone a process referred to as oxidation. So the magnesium has been oxidized to become magnesium 2+. Let us look at what has happened with the oxygen on the other hand. Now with the oxygen, initially its oxidation number was 0. Why? Because it's oxygen in its elemental form as a molecule, and it will have an oxidation number equal to 0. Now what has happened to the oxygen when it becomes magnesium oxide? Well, the oxidation number has changed from 0 and it has become -2. So what has happened to the oxidation number of the oxygen? Well, it has changed from 0 to -2. So we say that the oxidation number has decreased. If the oxidation number has decreased, what does that mean? It means that the oxygen has undergone a process of reduction, right? So it has undergone a process of reduction to become the oxide ion. We will explain how both these processes have occurred, right? So we're going to now write the half equations for the oxidation and also the half equation for the reduction, and then explain to you everything else that is associated with it. So the first step is to write the oxidation half process. Now in this oxidation half process, we said it's the magnesium that has undergone oxidation. So we started off with magnesium, and that magnesium became magnesium 2+. How does it become magnesium 2+? Well, it can only do so if it loses 2 electrons to become short of 2 electrons. So +2 electrons which are released. And those 2 electrons which have been released are the ones that are going to be gained by the other species that reacts with the magnesium, in this case oxygen. So this is the half reaction or the half process for the oxidation of magnesium to give you magnesium 2+. Secondly, we have the oxygen, but in this case, how many oxygens do we have? We've got 2 of them that undergo the process of reduction. So the oxygen, being 2 of them, each oxygen atom gains 2 electrons each oxygen atom gains 2 electrons to become the oxide, right, which has got a charge of -2. Take note, there are 2 oxygen atoms that form the molecule of oxygen, and I'm saying each oxygen atom requires 2 electrons to become the oxide molecule. So that means we are still short of 2 electrons. So what should happen? It means that the magnesium, we need another magnesium that's going to be available to lose 2 more electrons. So how do we bring about that balancing? Or what do we do? We need to balance the number of electrons. So what then happens is we just simply take the whole equation and multiply it by 2, because we need 2 more electrons. So this is going to become 2 mg, and then that becomes 2 mg2 plus 4 electrons. We now have 4 electrons available. And then now, so what needs to happen? Instead of having 2 electrons being gained by the oxygen, there are going to be 4 electrons that are going to be available. So we can change that to 4 electrons. Then we now have your 4 electrons, that which were lost by the magnesium are the 4 electrons that are going to be gained by the oxygen. So, and there are 2 of these oxygen atoms. So here we've got 1 at the moment, so there will be 2 of those. And hence, when you look at this now, we can now write the net equation for the process. And now that net equation is going to look like this. So in order for us to write the net equation, we would write what happens on the reactants, so that the sum of the reactants, so it's going to be 2 mg, that's the only reactant up here, plus your O2 plus the 4 electrons to give us the product. How many products we have? We've got 2 mg2 plus, then plus 4 electrons, and then plus 2 oxides that were given. And so now we then look for what can be like terms and collected together and simplify it. So we've got 4 electrons, and on that side we've got 4 electrons. If we transpose that, it becomes a minus, so those 4 electrons can cancel. We don't have anything else that is the same, so we've got our 2 mg plus our O2. It's going to give us our 2 mg2 plus 2 O2 minus. So in other words, your magnesium has been oxidized to magnesium 2 plus, and your oxygen has been reduced to your oxide. And there are 2 magnesium, there are 2 oxygens, and then the net charge on this side, the net charge is 0, and on the other side we've got 2 times 2 positive charges gives us 4 positive charges, and then on the other side 2 times minus 2 negative charges gives us 4 negative charges. So they also add each other out and it becomes equal to 0. That means there is the equation that's now balanced, both in terms of the species present as well as the ions present, or the charges that are present. So what is important to remember is that what is oxidation? Oxidation is what? Is increase in oxidation number, right? How does it happen? It happens through the loss of electrons, right? Just maybe without the -1, through the loss of electrons. And there is a species that brings about, so the species that will undergo oxidation is the reducing agent. So the reducing agent causes the other one to be reduced, and it will undergo oxidation. So in this case, your magnesium is going to cause the oxygen to be reduced, and therefore the magnesium is going to suffer an oxidation process. And then there is reduction. What happens with the reduction? It's the opposite of what we've just described about oxidation. So what is it? Is a decrease in oxidation number. How does it come about? It comes about the gain, or through the gain of electrons. Right, through the gain of electrons. And the species that suffers the reduction is the one that is referred to as the oxidizing agent. It will cause the other one to be oxidized, and after it has caused it to be oxidized, the species itself will suffer a reduction process. So these definitions are operational and functional, and you need to know them so that you're able to answer any question that comes or that can come requesting you to do so. I will give you one more example before we leave it to the next video. Here's an example. It says consider the following unbalanced reaction equation, and that reaction equation is Fe2 plus in solution, so it's already being given to you as ions, plus chlorine to give you your Fe3 plus your chloride. So these are all in aqueous solution, right? So we now want you to balance them, and then thereafter be able to identify the oxidizing agent, reducing agent, etc. And then to write the half equations for the reduction process, the oxidation process, as well as the net ionic equation, and also to balance it. So let's look at the first reaction. Well, the first species in the reaction. So the iron 2 starts as iron 2 plus. And then what happens to the iron 2 plus? Well, the first thing that we observe is that the oxidation number increases. So if the iron has an oxidation number that has increased, we know that it has undergone a process of oxidation. If it has undergone a process of oxidation, that means that the iron 2 is the reducing agent. If you have a look at this summary which we gave here, which we gave above here, right, that there's going to be an increase in oxidation number, loss of electrons. That means that it's the reducing agent. So we've already identified the species that's going to be the reducing agent. And then we look at your chlorine. Initially, your chlorine's got an oxidation number of 0. It's a molecule. As the molecule, it's got net charge equal to 0. But then what happens at the end? Well, that chlorine comes and it becomes the chloride. Its oxidation number has decreased. Why? It's moved from 0 to -1. So 0 is a higher number than -1. So we say the oxidation number decreases, and therefore the process that it has undergone is referred to as a reduction. Right? So if this is the reducing agent, that means this is going to be your oxidizing agent. You have identified basically all the species. Now you will write the half equations, and then when you write the half equations, you will be able to then balance that equation. So now let us look at the half equations that are involved. The first one that we're going to use, or that we're going to look at, is the oxidation process. Right, who was oxidized? It's the iron 2. So what happened to the iron 2? The iron 2 changed from iron 2 and became iron 3. How did that happen? Because the iron 2 lost an electron to become one electron short, and hence the increase in the oxidation number. So this is the half equation for that process. And then the second process that we're looking at is the reduction. Remember, these processes occur simultaneously, right? So we say this one, oxidation is loss. What did we observe? There's a loss of electrons. So the reduction is gain of what? Electrons. Whatever the electrons were lost, that's what the other species gains. So your chlorine gains electrons, but in this case, what are we observing? That there is one electron, and each chlorine is supposed to gain an electron, but we've got two chlorines, so we are short of electrons. That's the first bell that you get here to get our chlorides. We need to have two of these, so now there's an imbalance. So what must we do? This guy at the top here, where there's the oxidation, it needs to lose more electrons, so I multiply that by 2, and if I multiply this by 2, I'm therefore going to be able to say I now have each one of these iron 2s losing an electron to give me 2 iron 3s plus 2 electrons that have been lost. So that means now these 2 electrons are now available to come and be gained by the chlorine. So now each chlorine gains an electron, so these 2 electrons are enough to satisfy the needs of the chlorine to give you the chloride. So when you look at this, it looks now okay, it looks balanced. Each of those species now has the necessary number of electrons that it needs. We then look for the net ionic equation. So the net equation, right? And then we balance it. So we look at the ions. So you've got your 2Fe2 plus, 2Fe2 plus the chlorine plus the 2 electrons. They gave, or this is what was obtained, 2Fe3 plus the 2 electrons. That's for the top equation, plus what was obtained in the bottom equation, 2 chloride ions. And then we look at the number of electrons. That's what we can cancel, because that's what is common on both sides of the equation. So from there, we say there's nothing else that is common on both sides of the equation. So we now have our 2Fe2 plus our chlorine to give us our 2 iron 3 plus your 2 chloride ions. So check again for balance. Well, there are 2 positive charges. 2 times 2 gives you a total of 4 positive charges on the left hand side, and on the right hand side you've got 6 positive charges minus 2 negative charges. So that's going to give us a total of plus 4 charges, positive charges on the left hand side. And then you've got this in terms of species type. You've got iron, you also got iron, 2 of them. You've got chlorine, Cl2, and then you've got 2 Cls. So that means the equations are balanced. That is what you needed to look at, and you are supposed to also tell us which species was the oxidizing agent, reducing agent. Well, we say this here is going to be the reducing agent. Which part? The iron 2. And which part was the oxidizing agent? Is the chlorine, right? That Cl2 is the oxidizing agent. So that is what you need to be able to identify. 3 parts of the equation that are necessary: the oxidation process, the reduction process, and the net ionic process. Once you know all of them, you would have been able to answer the equations. Remember this mnemonic: oil, Reg, right? Standing for oxidation is loss, reduction is gain. So thank you for watching. If you liked it, please press like, share, and also like or subscribe to our YouTube channel. And we are looking forward to seeing you in the next video. Thank you very much.